the root of x. So when we solve these two equations simultaneously, we should be able to find the coordinates at point D as well as point O. So to do that, we write the first equation, y is equal to 3x. Then the second equation identified y is equal to 6 square root of x, like that. Now, this is our first equation and this is our second equation. So we can just do a substitution. So clearly here we are saying that y is 3x. Y is 3x. So meaning in the second equation, I can remove this y and replace it with 3x. So we write 3x is equal to 6 the root of x, like that. Then we can simplify this expression as much as we can. So reducing this equation by 3, like that, so that this disappears and we remain with x is equal to 2 square root of x, like that. Now, when we have an equation like this one, it is not easy to solve something like this. So what we're supposed to do is to try by all means to get rid of this root of x. So how do we do that? We can square both sides of the equation so that this square root on the other side disappears. So what we should have is the square of x, which is equal to, then square the other side of the equation, like that. Remember, this 2 is not supposed to be excluded because we are squaring everything so that the equation must be balanced. Whatever we have introduced this side of the equation must also be introduced this side. So this ensures that the equation is balanced. So we have x squared is equal to, then by the rules of indices, we know that this is 2 to the power 2, we get a 4. Then root of x to the power 2, the root would disappear, we just remain with the x, like that. Okay, so we can collect both variables so that they should be on one side of the equation. So we should have x squared minus 4x is equal to 0, like that. By factorization method, we say that x is common, then we have x minus 4, like that, is equal to 0. Then the first value of x, we say x is equal to 0, then the other one is x minus 4 is equal to 0. We can finish this one by transferring -4 on the other side of the equation. So we have x is equal to, when -4 goes on the other side, it will be 0 plus 4, which will be just x is equal to 4. So we have identified the two values of x. We have x is equal to 0 and x is equal to 4. So on our graph here, the positive 4 goes on the x-axis here. Then the other value of x, which is 0, goes here, like that. Now, as much as we have identified the values of x, we are supposed to also identify the value of y for each x value we have identified. So when x is equal to 4, what will be the value of y? So to find the value of y, we can pick any of the equations, either equation 1 or equation 2. But we look at the equation which is simpler. So I'll choose the first equation, but whichever equation we pick, the values must be equal. So we have y is equal to 3x, like that. So we say y is equal to 3. So for x is equal to 4, we substitute in this equation, like that. Then when we simplify, we should be able to get a 12, meaning that the value on the y-axis is 12. So here, on our y-axis, when x is equal to 4, y is equal to 12. You can as well try with the other equation and verify that you'll be able to get a 12, since the value of x is 4, and when we find the square root of 4, which we get a 2, then 2 times 6, we get a 12. So this is how we find the coordinates at these points. So we have 4, 12 and 0, 0. Now, speaking of the volume, when these three, when the shaded region is rotated about 360 degrees, we can just apply Washer's method. So that should be very simple because we have already identified the limits at which we are going to evaluate between 0 and 4. So I'll not solve that one, but you can give it a try. Just try to find the volume generated. Thank you.